Good afternoon, friends. I hope you are having a great time at Smart Home Virtual Connect. Now, to proceed further, we would like to have our next speaker, Dr. Amardeep Dugar, who's a trained architect and advocate for all the elements of lighting design, education, and research. Mr. Dr. Amardeep Dugar is the founding principal of Lighting. I hope you are having a great time at Smart Home Virtual. His notable achievements includes being named the outstanding young scientist at the India International Science Fest 2016 and 40 under 40 hottest lighting designers of in the world. 2017 by Lighting Design Magazine UK, amongst others. Aside from working on high profile projects and teaching at several architecture schools, he has been instrumental in conducting lighting workshop, educating students and professionals about the importance of lighting. We are very happy he accepted our invitation to speak at Smart Home Virtual Connect. He would like to address smart homes and workspaces evolution of lighting. Please welcome Dr. Amardeep Dugar.
Smart homes and workspaces, evolution of lighting. When I was asked to deliver a keynote lecture for the Smart Home Virtual Connect, I did spend some time trying to look up what is smart home workspaces, looking at some of the headlines. And these were the headlines that sprung up. LED lighting, the revolutionary innovation of smart home lighting. IoT in the workspace, smart office applications for better productivity. The smart office, a high-tech hybrid with a human touch. So all these headlines and all these news articles that I read while preparing for this lecture led me to a whole bunch of questions. And I've just tried to summarize these questions here into two larger questions. Is firstly, what revolutionary characteristics make lighting smart? And how do these characteristics impact the evolution of lighting? We are in the year 2020, the most memorable 2020. We all know this is a year that none of us was going to forget. But where does all this lead to? What is the future of smart lighting? How does lighting evolve with all these questions about smart? So I went about trying to understand the definitions of smart home, smart workspaces. And this is what came up in my research. A smart home, the definition of smart home is a home using internet connected digital devices to enable remote monitoring and management of appliances and systems such as lighting, heating, etc. So what it essentially means is that when you're away from home, you're able to monitor what is happening in your house with a mobile device or a computer by means of internet. So there's a smart security system that detects intruders. There's a smart lock that doesn't open until unless you give it permission to. There are cameras. It also goes on to detect hackers within a space if somebody's trying to hack into your system. There's also this other ability that it gives is if you have a senior citizen at home alone and the person falls in a bathroom, there's a detection of falls detection system that tells you that somebody has fallen and you need to take immediate precautions. There are motion and window sensors that for looking at what's happening inside and around your house. So that is when you're away. And when you reach your house, you can control the lighting, the air conditioning system, your audiovisual system, again, by means of your smart device, which is a mobile phone or a tablet or any other remote internet connected device. Definitely fairly comprehensive, this explanation and definition has been. The definition of smart workspace is use of technology to connect and encourage employees with their work environment through network platforms, software, IoT technologies, and sensors. Again, a fairly comprehensive definition where it means that let's talk about lighting, where it's a smart lighting system which detects if there are any employees working in the space and switches on the light. And if it doesn't have any detection of movement or work, the light either dims or switches off. There's a sensor that detects the temperature. So if there are too many employees, then the air conditioning system adjusts the temperature based on the number of employees. And if there are lesser employees, they automatically adjusts. There's a window tinting system or an automatic blind system. So when there is too much of daylight coming into the space causing glare, it automatically tints the windows, make it dimmer. So there's only an adequate amount of light that is coming inside. Again, fairly comprehensive definition. So when I was looking at what characteristics define smart, the key characteristics, these four came up. First is remote control. Second is connected network. Third is digital devices. And last but not the least, the Internet of Things. I did some further research into finding out where did all these technologies or technological innovations originate from? Who were the inventors of these technologies? And I had a bit of a blast from the past, where the first remote control, which is called teleautomation, was unveiled by the Serbian-American scientist and inventor Nikola Tesla in 1898. So there was a science exhibition at the Madison Square in New York City, and here he used the very first remote control device to control a toy boat, control the movement of a toy boat, and this completely enthralled the attendees of the science exhibition. This really got me thinking. So all these technologies that we talk about, smart, remote control technology, it isn't a futuristic technology. It is something which is more than 120 years old. So why is one going so gaga about it? And the same revelation happened to the other three characteristics as well. Connected network, or which we most popularly known as Bluetooth, was initiated by Niels Rydbeck and his group of scientists and technicians from Ericsson in 1989. So this was initiated for making the first wireless headsets using short-link radio technology. And this technology was later named as Bluetooth. Again, this technology is literally 31 years old. Nothing new. Digital devices, most popularly the LEDs, was invented by Shuji Nakamura and his group of scientists in 1993, where they invented the blue LED, which apparently kickstarted the digital lighting revolution. But a look at this whole thing further, you can see that LED as a technology, the first LED or the red LED, was invented in 1962. And then the amber or the yellow LED was invented in 1972. So again, these technologies are fairly old technology, literally 58 years now. And finally, the Internet of Things was first used by an executive from this company, Procter & Gamble, for product supply chain. And this was known as RFID, the radio frequency identification technology. And this was used for tagging different objects, different products. And then later on, it came to be known as the IoT or Internet of Things. This put me in a bit of a spot of bother, because I started this with a few questions, trying to answer questions, and I was left with a lot more questions. So in trying to find this whole definition of smart lighting and the way forward, Do mere technological innovations from the past define smart lighting? I mean, is that all there is to smart lighting? Just a few technological innovations, which are probably what, 1898, 1989, 1993, 1999. So I was hoping to see from 2020, we'll be looking to the future, maybe 2030 or 2050. But I'm literally looking back in the past. And if this is not it, what could be an evolutionary way forward for smart lighting in the future? Did some more further research, and I came up with a very interesting article by a designer named Brad Koiner. And Brad has listed 6 points for the way forward and thought those would be very interesting to share with this elite audience here at this conference. So a little bit of a dive into the future. The first technology that Brad shared is luminous surfaces, where light-emitting building envelopes will start creating continuous fluid visual experiences. Now, architects, interior designers are always on the verge of looking at something which is more innovative and breakthrough. So instead of just having light fixtures, what if the walls, the ceilings, the floor start becoming luminous surfaces and emanating light? So that this whole need of installing light fixtures will become derelict. We won't need to do that anymore. And the advantage this would give is that this whole concept of lighting for health, circadian light or melanoping light or whatever it's called, it starts receiving maximum biological, physiological response, because the entire surface, the volume of your architecture of your space, the entire building envelope is creating an almost light emanating like daylight, which is daylight is very volumetric. It comes in from all direction. That, in my opinion, is something which is really revolutionary. Second point is data and media-driven experiences. Preset controls have to evolve. And instead of just controlling a couple of preset scenes, where we have just one scene for dinner scene, one scene which is for music scene, or one scene for maintenance scene, the entire lighting control system becomes a comprehensive experience management system. What does this mean, or what does this entail? It means that digital lighting starts transforming the physical architecture into a branded virtual experience. So whenever you design a corporate building, apart from being a physical space, the client is always looking at marketing, and the idea is to give experiences to the users. And with such form of a comprehensive experience management system, lighting will become a sort of a brand identity, and people will actually start experiencing what brand, and it becomes a virtual branded experience, and the architecture becomes a portal to the virtual world with such a media-driven experience, data and media-driven experience. Third is interactive spaces. We as human beings are always looking for meaningful interactions, and lighting can become a mode of that meaningful interaction, because currently lighting is only used for function of visibility, accessibility. But what if light starts delivering content and delight along with the function? By content and delight, it means that light becomes a source of providing information, and the lighting starts becoming an interactive, responding to touch, proximity, and other embodied activity. So just imagine a user who's come with a very bad mood. He has an angry face, or maybe the body language of the person is showing angry, and the lighting control system is able to understand that, and it responds in a very subtle manner of giving a very subtle kind of a lighting mood, so that it will help ease the anger, the tension in the body. And that's what becomes a meaningful interaction. Or for that matter, somebody is very sad and he has a very sad face or a sad body language, and lighting understands that, and it subtly provides that form of a interactive visual experience where the lighting soothingly changes the mood of the person, makes the person happy. That's when lighting becomes interactive. That's when the interactions with the space and architecture and the user becomes much more meaningful. Definitely thought-provoking. Fourth is digital twin commissioning. Now, building information modeling or BIM is the next big thing in architecture. We all know everybody is using building information modeling. Now, what if live simulations in building information modeling start reducing on-site commissioning costs and time? And considering these COVID times, a lot of designers are confined within their homes, not even in their offices, not able to go to site. And such live simulations with BIM models will actually help in enabling design better. So, for example, you have a virtual lighting with a cloud connected BIM model, and you're controlling the lighting. And that cloud connected BIM controls the real lighting hardware at site. So all the times wasted of going and coming to site is reduced, because right from the luxury of the home or the office, the designer is able to control the lighting, program the lighting, provide the right kind of scene. And with real photorealistic BIM models, the designer is able to see how the lighting scene is. And this cloud connected BIM model controls the lighting at the site. So if the designer may be seated in the United States and the project could be in India, and through this cloud connected BIM models, this designer will be actually able to control and program the entire lighting scene from far away. And this is something, in my perception, pretty revolutionary. It saves a lot of time, it saves a lot of cost, a lot of energy, and working becomes a lot more pleasure and fun with such form of digital twin commissioning. 5 is circular economy. Now we need smart maintenance program, especially luminaire manufacturers. They need to come up with smarter maintenance programs by which they're able to monitor and broadcast the lighting system's performance. So it's not just about supplying the light fixture. Every light fixture or luminaire is tagged, and once the fixture is installed at site, the manufacturer or the supplier who supplied these fixtures is able to monitor how the functioning of the lighting is in real time. And if something goes wrong, one can take appropriate measures to correct that. So that is something which is revolutionary. And what we also need is a more cyclic or a circular economy where lighting systems are made or manufactured with bio-based materials. This would drastically reduce embodied energy, the amount of toxicity that is emanated into the environment. So all the toxic waste production is reduced because all products that are bio-based, costs are reduced, and there's a much more recycling process in place where once the light fixture reaches its end of life, it comes back to the manufacturer, it's recycled and can be brought back into production and into the market again. So there's circular thing happening. There is very less landfill and very less consumption of raw material, and that would be very much beneficial to the environment. And finally, sixth component is the use of DC power and net zero energy. Now, this is not constrained to lighting. This is to the entire building management system, because we all know that LED especially uses DC power or direct current. So it is a bit foolhardy to supply the entire electricity in alternating current, which is AC, which normally happens from our grid. And the supply happens, this AC alternating current is then converted to DC current. There's so many losses of energy in this conversion in terms of heat, and then light is supplied. So what if there is localized energy resiliency within the building? So buildings will start increasingly going off grid. Whatever energy that is produced in the building is within the building itself either through solar cells or micro wind technologies. And right from the car of use of electric car, the LED lighting, all the appliances and devices operate on DC current. So everything will be locally produced and locally used up. So this will reduce cost, and buildings will slowly and surely, all buildings will start completely becoming net zero energy because they're not using any energy from the grid. And each building will become resilient, and the entire community will become resilient, energy resilient, and they will not be dependent on grid technology. And that will be very much good for the future. So in closing of this lecture, what would be the evolutionary way forward? This to answer my own question. Firstly, there needs to be a major transformation in designers. By designers, I mean architects, landscape architects, interior designers, lighting designers, product designers. They all have to transform from being mere spatial designers or designing spaces into experiential designers. This will involve a completely user experience based design, which will be scripting, storyboarding, and then simulating. Beg your pardon. So when you have a proper script to how the user will experience the entire space, then the script will be taken in the form of a storyboard, graphically explained as to what the various experiences could be in a space. And then finally, you simulate that using build BIM models, virtual lighting, and able to completely see what your design would be. Next thing would be an obligation by these designers towards a bright and right future. This would require thinking in terms of thinking completely during the design stage itself. You out-design the waste and pollution. So the designers would really start thinking where there would be no waste, no pollution, and then mapping. You map the entire life cycle of the products. So for example, in terms of lighting, you map the entire life cycle right from production to usage and to regeneration. So you have a regenerative natural system where instead of the light fixture being disposed, it's brought back into the cycle of recycling and then taken to. So the entire product is thoroughly mapped. And finally, specifying, because we as designers were specifying the future. So we always keep products and materials in use all the time. So this would become a regenerative natural system specifically. With this, I'd like to end my lecture. Thank you very much.
Thank you, Mr. Amardeep, for speaking at our conference.
Thank you for inviting me for this conference. Can you hear me?
Yes, I can hear you.
Okay.
Someone has a question for you, Mr. Gautam.
Okay.
Which is better protocol for home automation, Wi-Fi or Zigbee? I think I'm not sure whether you would like to answer this, but if you have any view on it. I think he asked in your session. Which is better protocol for home automation, Wi-Fi or Zigbee? I think
it depends, because it depends on the kind of application is what I would say, because both have their advantages.
I think you are on mute.
Both have their advantages and disadvantages. So you just have to see what is useful.
Thank you, sir. We will, in fact, this video will remain for entire 3 days. All the questions we will put to you, and in case you want to answer to these guys.
Sure.
Okay. Thank you very much, Dr. Amadi. Thank you.
Great. Thank you. Bye-bye.